Here's the lesson for day 2, unit rates. Okay, there are 2 ways we can go about solving unit rates, so that's what we're going to explore in this lesson. Our first example shows us our first way. So the problem says 2 students are solving the same problem. At a hardware store, they can cut a length of rope off of a big roll, so you can buy any length you like. The cost for 6 feet of rope is $7.50. How much would you pay for 50 feet of rope at this rate? Kieran knows he can solve the problem this way. So he took the information and put it in a table. 6 feet of rope cost $7.50. And then what he did for the next row was get the cost for 1 foot of rope. So in order to do that, he took his cost, $7.50, and divided it by 6. So you can see here, the $1.25 is the cost for 1 foot of rope. So then in order to find the cost for 50 feet of rope, we would simply take our price for 1 and take our cost for 1 foot of rope and multiply it by how many feet we are trying to buy. Remember, we multiplied with a decimal, so we've got to move our decimal 2 times in our answer. So he would spend $62.50 for 50 feet of rope. That is one way to solve unit rate problems. Divide to get the cost for 1, and then multiply by however it is, how many it is you're needing. Okay? The next way you could solve it, instead of dividing and multiplying, you can set a proportion. Okay, we are comparing feet and dollars. So we know that 6 feet of rope cost us $7.50. And then we're trying to figure out how much 50 feet of rope would cost. So then we would cross multiply and divide like we've been doing with all of our percent problems. We're not going to solve it because I know the answer is going to be 62.50. So if we take a look here, I'm going to show you the proportion method. So Tyler swims at a constant speed of 5 meters every 4 seconds. So we can see that information has already been put into the table for us. We want to know how long it will take him to swim 114 meters. So we're comparing meters and seconds. So I'm going to use M and S for my proportion. I know that 5 meters he completed in 4 seconds. And then here we have 114 meters. So that's going to go on top. We want to know how many seconds that's going to take. So we cross multiply, we get 5x. Cross multiply, 114 times 4 is 456. To get x by itself, we divide by 5. We do top in, bottom out. 5 will not go into 4, but it will go into 45 9 times. Subtract, nothing left. Bring down the 6. 5 goes into 6 1 time. For 5, subtract 1 left. Decimal, drop a 0. 5 goes into 10 2 times. And we're done. So we know in 114 meters, he's going to be, it's going to take 91.2 seconds. Okay, next question. We have a factory produces 3 bottles of sparkling water for every 8 bottles of plain water. So I'm going to put that in our table here. 3 bottles of sparkling water goes for every 8 bottles of plain water. We want to know how many bottles of sparkling water the company can produce when it makes 600 bottles of plain water. So here we are comparing sparkling water and plain water. So I'm just going to use S and P in my proportion. I know that every 3 bottles of sparkling water, they could make 8 bottles of plain water. And then we want to know how many bottles of sparkling water they can make with 600 bottles of plain water. So now we cross multiply. I'm going to have 8x. Cross multiply. 6 times 3 is 18. So 600 times 3 is 1800. To get x by itself, we divide both sides by 8. And then we can do top in, bottom out, divide. 8 will not go into 1, but it will go into 18 2 times. That gives us 16. Subtract, we have 2 left. 8 into 20 goes 2 times. Again for 16. Subtract, we have 4 left. And finally, 8 into 40 goes 5 times. Subtract, we have nothing left over. So x is going to be 225 bottles of sparkling water goes for 600 bottles of plain water. Okay, and then our last example. A certain shade of light blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. How much white paint would you need to mix with 4 quarts of blue paint? So we're making light blue paint with blue and white. So I'm going to set up a proportion and I'm going to use B for blue and W for white. Right here, I see it's going to take me 1.5 quarts of blue paint. So I'm going to turn that 1.5 into a decimal, 1.5. And then 5 quarts of white paint. And then we want to know how much white paint is going to be needed for 4 quarts of blue. So 4 is going to go on top with blue. X will go on bottom to figure out how much white paint. Cross multiply, we're going to have 1.5x. Cross multiply, 5 times 4 is 20. To get x by itself, we divide both sides by 1.5. Top number goes in, bottom number goes out. We cannot divide with the decimal outside, so we have to move it one place to the right. And then whatever we do outside, we have to do inside. Whole number 20, the decimal starts at the back. We moved it once outside, so we're going to move it once inside, and I'm going to bring it to the top and fill in my empty spot with the 0. Now, 15 will not go into 2, but it will go into 20 one time. 20 minus 15 leaves us with 5. Drop a 0. 15 into 50 goes 3 times. That gives us 45. 50 minus 45 is 5. Again, I already have my decimal up here, so I can drop a 0, and I'm back at 50, which we know is going to be 3 times, which gives us 45, and that's just going to keep happening over and over and over. So we simply indicate that that number is going to repeat by putting a line on top of it. So we know it's going to take 13.3 repeating quarts of white paint to mix with our blue paint. So to solve unit rate problems, you can do like the first example where you divide to find the price of 1 and then multiply, or you can use our idea of setting up proportions like we've been doing throughout this entire unit.